Let's look at example 4. In example 4, I give you this equation right here, and I give you that x equals 2i is one of the zeros, and you are supposed to use that to find the rest of them. Well, the first thing we can do is use the conjugate pairs idea. If x equals 2i is a zero, then we know that x equals negative 2i must also be one of the zeros. So if we take the zeros and put them in factored form, that gives me x minus 2i, x plus 2i. That has to be two of my factors. Now, if I take these two factors and FOIL them together to get my irreducible quadratic, I get x times x is x squared, x times 2i is 2i, positive 2ix. Negative 2i times x is negative 2ix, and negative 2i times positive 2i is negative 4i squared. 2ix minus 2ix go away, so we get x squared. I squared becomes negative 1, so negative 4 times negative 1 becomes a positive 4. So these FOIL together to become that irreducible quadratic. And here's what I'm going to do. I know that this is one of my factors. So to find the rest of them, I can take my big equation and divide by my irreducible quadratic. And you actually have to do it this way because you actually cannot do synthetic division with imaginary numbers. It doesn't work, unfortunately. So instead of doing synthetic division, you have to find your conjugate pair, FOIL them together to get your irreducible quadratic. So let's do my long division. I have x squared plus 4, my irreducible quadratic, divided by x to the 4th minus x cubed minus 2x squared minus 4x minus 24. And let's review our long division. So x squared times what is x to the 4th? Well, that's an x squared. Put it in the x squared column. Distribute x squared times x squared is x to the 4th. X squared times 4x is a positive 4x squared. Better put it in the x squared column. Change our signs. So x to the 4th minus x to the 4th goes away. Bring down my negative x cubed. Negative 2x squared negative 2x squared minus 4x squared is negative 6x squared. Bring down my next term and do it all over again. X squared times what is negative x cubed? That's negative x. Distribute negative x times x squared is negative x cubed. Negative x times 4 is a negative 4x. Change the signs. Those go away. Bring my negative 6x squared down. Those go away. Bring down my negative 24. And last step, x squared times what is negative 6x squared? That's a negative 6. So distribute. Negative 6 times x squared is negative 6x squared. Negative 6 times 4 is negative 24. Change the signs. And that goes away. And ta-da, we have a remainder of 0. So there is my long division. And now that my long division is done, I can write my multiplication statement. And my multiplication statement is my irreducible quadratic, x squared plus 4, times this answer I got, x squared minus x minus 6, which we can now fully factor. So what multiplies to negative 6 and adds to negative 1? That gives me x minus 3 and x plus 2. And now I can take my irreducible quadratic back to my imaginary ones. And we finally have our fully factored form. So I did my long division, factored that out. Now that I have fully factored form, I can set them each equal to 0 to find my roots. So x equals 2i, x equals negative 2i, x equals 3, and x equals negative 2. They all have a multiplicity of 1. So this was a degree 4, and I have 4 answers. There's all your zeros. And of course B, factor f to our linear and irreducible quadratics. That would be this step right here. So it's just before we went down to our imaginary level. So that's x squared plus 4. There's my irreducible quadratic. And x minus 3 and x plus 2. That is factored with my irreducible quadratic. So that was a little long division review and using our conjugate pairs to come up with the rest of my factors. We have one more video to go and then you're done with 2.5.